Hello my friends, and welcome back to Sky Creative Channel. Today we're taking you on an extraordinary journey through 8 cutting-edge production facilities around the globe. Grab your coffee and settle in. You're about to see manufacturing processes that will absolutely blow your mind. Let's kick things off with something truly impressive: the complete manufacturing process at THOUSANDTHS, one of Turkey's premier firearms manufacturers. What you're witnessing here isn't just metalworking, it's precision engineering at its absolute finest. Watch as high-grade steel billets enter the facility. These aren't your average steel blocks. We're talking about specially formulated alloys designed to withstand tremendous pressures and maintain dimensional stability under extreme conditions. The first stop, the CNC machining center, where computer-controlled precision takes over. Those massive CNC machines you see aren't just cutting metal, they're sculpting it with tolerances measured in thousandths of an inch. The slide assembly alone requires over 47 different machining operations. Notice how the coolant system continuously bathes the cutting tools? That's maintaining temperatures within 2 degrees Celsius to prevent thermal expansion that could throw off those critical dimensions. Here comes the magic heat treatment. Those glowing chambers reach precisely 450 degrees Fahrenheit, transforming the molecular structure of the steel. The controlled cooling process, called quenching, happens in specialized oil baths that cool the parts at exactly the right rate. Too fast, and you get brittleness. Too slow, and you lose hardness. Watch this incredible surface finishing process. Those rotating drums contain ceramic media that tumbles with the parts for hours, creating that mirror-like finish you see on the final product. But it's not just about looks. This process also removes microscopic stress points that could lead to failure. The assembly line operates like a Swiss watch. Each worker is responsible for specific operations, and every single pistol goes through a 127-point quality inspection. That testing booth you see? It's where each firearm is proof tested with special high-pressure cartridges to ensure safety and reliability. Now we're moving into the precision world of ammunition manufacturing at THOUSANDTHS machinery. Creating reliable ammunition requires absolutely zero tolerance for error. Lives literally depend on it. It all starts with brass strips feeding into these incredible progressive presses. Watch how the metal flows through multiple forming dies. Each one gradually shapes what will become the cartridge case. The brass undergoes 7 distinct forming operations, each one monitored by sensors that detect variations as small as 0.0001 inches. These aren't ordinary stamping machines. The precision forming systems operating at 800 strokes per minute. The cupping operation forms the basic shape, then multiple drawing operations gradually stretch the brass to exact specifications. Notice how each die is temperature controlled? That's maintaining dimensional consistency as the metalwork hardens during forming. Here's where science meets manufacturing. The brass cases enter an annealing furnace where they're heated to exactly 650 degrees Fahrenheit, then rapidly cooled. This process relieves internal stresses and restores the brass's ductility, preventing case splits during firing. Head stamping and primer pocket formation. Watch this fascinating header machine in action. It simultaneously forms the case head, creates the primer pocket to precise depth specifications, and stamps the head stamp information. The pressure required? Over 40 tons per case, but applied with surgical precision. Every single case passes through automated inspection systems using laser measurement and computer vision. Those rejected cases you see being automatically sorted out? They failed tolerances measured in 10,000ths of an inch. The inspection system checks 23 different dimensions in under 2 seconds per case. The progressive loading machines you're seeing are marvels of precision. Each powder charge is weighed to within 0.1 grains. That's about the weight of a human hair. The bullet seating operation applies exactly 847 pounds of pressure to ensure consistent seating depth, which directly affects accuracy and pressure. The completed cartridges undergo ballistic testing in specialized pressure barrels. Random samples from each lot are fired to verify velocity consistency and pressure specifications. This isn't just quality control, it's ensuring that every round performs exactly as intended. Now let's shift gears to something completely different but equally fascinating: the production of hexagonal wire mesh for gabion baskets. These seemingly simple wire structures are engineering marvels used in everything from erosion control to flood management. Those massive spools contain galvanized steel wire that's been precisely calibrated for strength and ductility. The wire feeding system maintains constant tension. Too loose and you get irregular mesh. Too tight and the wire breaks. Each spool contains over 2 miles of wire. Here's where it gets really interesting. Watch how this incredible machine creates that distinctive hexagonal pattern. The twisting mechanism operates with multiple spindles, each one rotating at precisely calculated speeds to create uniform twist angles. Those twists aren't random. They're engineered to distribute load evenly across the entire mesh structure. The magic happens in the farming section, where individual wires are woven into that characteristic hexagonal pattern. Each hexagon measures exactly 80 millimeters across. Any variation would compromise the structural integrity of the final gabion. The machine creates 47 hexagons per minute, with mechanical precision that's absolutely mesmerizing to watch. Notice those heavier wires being integrated at the edges? Those are selvage wires, and they're 25% thicker than the mesh wires. They provide structural support and create attachment points for connecting multiple gabion baskets. The integration process requires perfect timing. The selvage wire must be inserted at exactly the right moment in the weaving cycle. Those sensors you see monitoring the process aren't just counting production. They're measuring wire tension, twist consistency, and dimensional accuracy in real time. If any parameter drifts outside specifications, the machine automatically adjusts or stops production. The final step creates those massive rolls of mesh. The cutting mechanism uses pneumatic shears that can slice through the entire width of mesh in under 3 seconds. Each roll contains exactly 50 meters of mesh, precision that's maintained through electronic measurement systems. Let's cool things down with a look at precision fan manufacturing at King Fortune Electrical in Taiwan. What looks like a simple household appliance is actually a masterpiece of aerodynamic engineering and precision manufacturing. The heart of every fan is its motor, and King Fortune's assembly process is poetry in motion. Watch how those copper windings are precisely positioned using automated coil winding machines. Each motor receives exactly 847 turns of copper wire, wound to tolerances that ensure perfect magnetic field distribution. Those fan blades aren't just shaped randomly, they're aerodynamically optimized using computer modeling. The injection molding process uses specialized ABS plastic heated to exactly 437 degrees Fahrenheit. Each blade is formed under 200 tons of pressure, creating that perfect curve that maximizes airflow while minimizing noise. Here's something most people never think about: fan blade balancing. Each assembled fan head spins through a computerized balancing system. If the rotation isn't perfectly balanced, small weights are automatically added to specific locations. This process eliminates the vibration that would otherwise reduce motor life and create unwanted noise. The housing assembly process combines precision with speed. Those robotic assembly systems position components with repeatability measured in hundredths of an inch. The final assembly includes 23 different components, each one positioned and secured in a carefully choreographed sequence. Every single fan undergoes performance testing in specialized chambers that measure airflow, power consumption, and noise levels. The testing protocol simulates 5 years of continuous operation in just 4 hours, ensuring long-term reliability for consumers. Now we're diving into the world of automated steel mesh production, a process that combines robotics, precision welding, and quality control into one seamless operation. Those wire feeding systems you see aren't just feeding wire, they're positioning each strand with millimeter precision. The longitudinal wires feed at exactly 150 millimeters intervals, while the cross wires maintain 200 millimeter spacing. Watch this incredible welding process in action. Those aren't traditional arc welds. This is resistance welding, where electrical current passes through the wire intersection, creating heat through resistance. Each weld point receives exactly 850 amps for 0.3 seconds, creating a molecular bond between the wires that's actually stronger than the original wire. Those sensors monitoring each weld aren't just checking if a weld exists. They're analyzing weld quality through electrical resistance measurements. The cutting system uses hydraulic shears capable of slicing through the entire mesh width in one clean cut. The handling system then moves these 12-foot by 8-foot mesh panels using vacuum lift systems that prevent distortion of the welded joints. Here's something you've probably never seen before: the specialized machinery that handles pocket spring coils for mattress manufacturing. This Atlanta Attachment Model 1409 is a marvel of mechanical engineering designed for one very specific task. Those round bales contain thousands of individually wrapped pocket springs, compressed under enormous pressure for shipping efficiency. The unbaler's hydraulic lifting system can handle bales weighing up to 200 pounds, positioning them with precision for the unwrapping process. Watch how the machine automatically locates and cuts the binding material. This isn't random. Optical sensors identify the binding pattern, and pneumatic cutters slice through the strapping at precisely calculated points to ensure controlled expansion of the compressed springs. The real magic happens in the separation system. As the bale expands, individual pocket springs are mechanically separated and fed into the distribution system. Each spring must maintain its individual fabric pocket integrity. Any damage here would compromise the final mattress quality. The springs pass through an automated inspection system that checks for damaged pockets, deformed springs, and proper spring tension. Rejected springs are automatically diverted, while accepted ones continue to the mattress assembly line. The system processes over 400 springs per minute with remarkable consistency. Now we're entering the precision world of Elora's torque wrench manufacturing in Germany, where mechanical precision meets measurement accuracy that can literally mean the difference between success and catastrophic failure in critical applications. The process begins with high-grade chrome vanadium steel billets heated to 100 degrees Fahrenheit. Watch how those massive forging hammers shape the basic wrench form with 400 tons of force. This isn't just shaping metal, it's aligning the grain structure for maximum strength and reliability. Those Swiss-made CNC machines you see are creating the precision surfaces that make accurate torque measurement possible. The ratchet mechanism requires 17 different cutting operations, each one held to tolerances of plus or minus 0.0002 inches. That's less than the thickness of a human hair. The heat treatment process is absolutely critical for torque wrenches. The steel undergoes a complex thermal cycle, heating to 550 degrees, oil quenching to 200 degrees, then tempering at 750 degrees. This creates a hardness gradient, hard surfaces for wear resistance, but a tough core for shock resistance. Here's where precision becomes critical. The calibration spring that determines torque accuracy is manufactured to tolerances measured in thousandths of a pound. Each spring is individually tested and matched to its specific wrench body to ensure calibration accuracy within 3% throughout the tool's working range. Every single torque wrench undergoes individual calibration using certified reference standards traceable to national measurement standards. The calibration process involves 15 different torque values across the wrench's range, with each measurement recorded and the tool adjusted as necessary. The final step involves durability testing, where each wrench performs 10,000 torque cycles while maintaining accuracy. Those that pass receive individual calibration certificates. You're guaranteed that when the specification calls for 85 foot-pounds, that's exactly what you'll get. Let's conclude our journey with something that showcases the absolute pinnacle of chemical processing and mechanical precision, Henneke's Multiflex Continuous Foam Production System from Germany. What you're witnessing is chemical engineering at its finest. The Multiflex system meters polyol, isocyanate, water, catalysts, and blowing agents with precision measured in grams per minute. Each component must be delivered at exactly the right temperature, pressure, and flow rate. We're talking about tolerances that affect the molecular structure of the final product. That mixing head operates at pressures exceeding 2000 psi, creating a chemical reaction that must be precisely controlled. The mixing occurs in under 0.8 seconds, but during that time the chemical components undergo a complex reaction that determines cell structure, density, and physical properties of the final foam. The conveyor system isn't just moving foam, it's providing a controlled environment for the foaming reaction. Notice how the sides automatically adjust to contain the expanding foam? The system maintains precise height control while accommodating the 40-fold volume expansion that occurs during the foaming process. Those infrared sensors aren't just monitoring, they're controlling the foaming reaction through precise temperature management. The reaction is exothermic, generating its own heat, but the cooling and heating zones along the conveyor ensure optimal cell structure development. The cutting system uses oscillating knives that slice through foam moving at 45 feet per minute. But before cutting, laser measurement systems verify thickness uniformity across the entire width. Any deviation triggers automatic density adjustment in the mixing system. The finished foam sheets emerging from this system have properties controlled to incredible precision, density variations less than 2%, cell structure uniformity that ensures consistent performance, and physical properties that meet specifications developed through decades of materials science research.